Friends, today I am going to discuss one more important lifting calculation. Here we are using a bracket, steel bracket or steel hook you can say. It is a steel plate having a dimension of 300 by 400 and 20 of thickness, welded to a truss beam with 15 weld thickness, and there is a 300 side and another 300 side. The hole is punched 30 away from the edges, and a load of 10 ton is planned to suspend from this hole. Uh, Now we have to decide whether this plate or bracket arrangement is okay for safely suspending this 10 ton load or not. For this case, electrode for welding is uses E7018, for which factor of safety is generally taken at approximately 60% of strength, that is 1.5 to 2 factor of safety. And yielding state for the mild steel is taken around 250 MPa, and 1 ton means equivalent to almost 10 kilonewton, or 10 ton means 99.6 kilonewton, means almost 100 kilonewton. So we have to see whether this arrangement is fit to lift 10 ton or 100 kilonewton load or not. So in this arrangement, what are the load factor is actually affecting this case? First case is welding load, whether welding is sufficient, welding strength is sufficient for carrying this load. Next one is there is a tearing load. Tearing out is or next one is searing, and another is crushing. These four types of load is affecting here. So one by one we will calculate all the four. First of all, welding load. For welding load we are using here electrode. Which type of electrode we are using? E7018. E7018 means its strength of E7018 is generally 70,000 psi. 70,000 psi means it is almost 485, 483 MPa actually. If you convert this, it will give you 483 megapascal. But for factor of safety, we are taking 60%. So 60% of this will be 483 into 6.6. How much? This will give you around 289.8 megapascal. This is actually welding sigma, effective welding sigma. Okay, so how much will be the welding load? For this we need to calculate the area also. Actually welding load is what? Welding load is that is sigma weld and effective area, welding area. Now welding area is how much? For this we know 15 thickness. So effective thickness is root 2 into T, that is effective thickness 0.77 into T means 15. Okay, and this will give you 10.67. And what will be the length? Effective length will be over 300 one side, another side is 300. total 600 mm. So total area will be, effective area will be 600 into 10.6. So ultimately calculation will be how much? Weld effective 600 10.6 into 289.8. This will give you ultimately 1 4 sorry 1843 kilonewton. 1843 kilonewton means you divide it 10 means it will be approximately 184 newton. 184 ton. So 184 14 184. So 184 ton capacity is okay. Welding load is okay because we uh, need to pick up on 10 ton. So welding is sufficient to carry the load. There is no problem with the welding. Next case, tearing is okay. For tearing is, what is the length? We have taken hole center 30 meter. Hole center is how much? 30 away. And what is the residual steel length? Because the dimension is 50 the dia is 50 so residual length is 5 and thickness of the plate is 20. So affected area will be actually for your tearing case. For tearing area for tearing is how much? Oh, area of tearing will be your 5 into 20. 5 is the effective length and T is the thickness of the plate. So effective length will be 5 into 20. 20 is the thickness. So effective area will be 5 into 20, that is 100 square. In this case, so L into T, effective length is, that is 30 minus 25, that is 5. T is the thickness of the plate 20, and for the mild steel sigma is 250. So how much will be? This is 100. This will be 100. 100 into 250 means 25,000 Newton. 25,000 Newton means 25 kilonewton. 25 kilonewton. If you convert this ton, it will be 2.5 ton. So this tearing load is not sufficient because it is not nearing to 10 ton. So it will not allow. Again, shearing, same 5 into 20 into for shearing generally it is half of strength is taken, half of this will take at least 60% of that, that is around 60% 0.6 of 250. You can take half also, generally it is So it will give you how much? 15 15,000 Newton, means 15 kilonewton or 1.5 ton. This is also not okay because it is not nearing to 10 ton crushing. For the case of crushing, we have to take the dimension of the hole. Dia of the hole is what? 50. Hole dia is 50, and thickness of the plate is your 20. And in this case, actually, we will take factor of say 1.5 times up to 50. Uh, this will give you around 375,000 Newton on 375 kilonewton on 37 ton. So 37.5 ton. This is okay. So your crushing and bending load is okay, but tearing and shearing load will not allow. So you cannot use this arrangement, for lifting 10 ton. Maximum how much you can lift by this arrangement? Only 1.5 ton. Maximum 1.5 ton can be can lifted by this bracket. So actually, what is the reason for this? Definitely the main reason is we are taking the hole near to the edge. Only 5 gap is there. But you have to shift this hole to the depth. At least your dimension of the this distance this distance should be 1 point greater than 1.5 d. Hole dia, where hole dia is 50, means for this case you generally 1.5 into 50, 75 this distance. Instead of 30, you should have taken 75 then it would be sufficient to carry this load. So before punching any hole in the steel bracket or welding, you should calculate all this dimension to suspend the load. I think it is clear to you and helpful for calculation of lifting load. Thank you for listening.